Let's call this problem 1. A ball is thrown from the top of a 45-meter building at an angle of 30 degrees above the horizontal and at a speed of 20 meters per second. We want to find out how long does it take to hit the ground, how fast is it going, what direction is it going, and how far away from the bottom of the building is it when it hits the ground. So in this type of problem, what you want to do first is draw a picture of it if they don't give you a picture. So here's a picture showing the situation. We've got a ball thrown from the top of a building, travels in a parabolic path, hits the ground somewhere away from the building. Next thing you want to do is identify the information you're given and the things you're trying to find. So we're told that the building is 45 meters tall, the initial speed of the ball is 20 meters per second, and it's directed at an angle of 30 degrees above the horizontal. We're asked to find how fast it's going just before it hits the ground, what direction is it going, and how far away from the base of the building is the ball when it hits the ground. First thing to do in these types of problems is identify what type of problem it is. In this problem, it should be obvious that it's projectile motion. So in projectile motion problems, I have equations like this and others. So the first question, how long does it take to hit the ground? So one of the things we need to do is put an origin, a coordinate system on this picture, if one is not already given to us. So let's put our origin down here. This is positive x, and this is positive y. Now, given that coordinate system, I can say that my final y position is 0. My initial y position is a positive 45. My initial velocity looks like this, which I can break up into x and y components, where this angle is 30 degrees. V0x is the initial speed times the cosine of 30 because it's adjacent to the 30 degrees. And V0y is the initial speed times the sine of 30 because the y component is opposite the 30 degrees. The acceleration in the y direction is down, and it has a value of g. So because I defined up as positive, that's negative 9.8 meters per second squared. So if I plug these values in, my final y position, initial y, then that's a quadratic equation in time. Remember the form of quadratic equations and the quadratic formula. So time here is just and that gives me and because negative times don't apply to our problem, it takes 4.22 seconds to reach the ground. Now part B, we want to know how fast it's going. The way we're going to do that is we're going to find the final x and y speeds and calculate v final from that. Remember, there is no acceleration in the x direction, so v final x is just v0x So the final x velocity is 17.32 meters per second. The final y velocity is negative 31.356 meters per second. And so the magnitude of the final velocity is 35.8 meters per second. And the direction and here I'm just using magnitudes. I'm not putting the minus sign in because the picture tells me how the angle is oriented. So 61.1 degrees below the horizontal. Now part D, calculate how far away from the base of the building it is when it hits the ground. Now that we know the time that it takes to hit the ground, we can calculate how far away it is. That's it. Distance is 73.1 meters from the base of the building.